We often imagine nature bathed in sunlight, vibrant flowers, dazzling colors, shimmering feathers. But let me tell you a secret. Half of life on this planet actually works the night shift. While we sleep, a vast biological battle unfolds outside. Darkness is not merely the absence of light. In evolutionary biology, darkness is a massive opportunity, an untapped resource, and a ruthless laboratory. So why would a creature reject the sun's abundant energy and choose the cold, blind dark instead? The answer takes us back millions of years to the heavy footsteps of dinosaurs. Today we'll explore how eyes, ears, and even skin transformed into survival-grade superweapons. Turn off the lights. We're starting. Let's rewind time by 100 million years to the Mesozoic era. During the day, dinosaurs were the undisputed rulers of the planet. If you were a mammal and stepped outside in daylight, it would likely be the end of you. Scientists call this the nocturnal bottleneck hypothesis. Our ancestors had only one option to survive: wake up when the dinosaurs went to sleep. But this came at a biological cost. To gain night vision, they had to give up color vision. This is why, unlike humans, most mammals cannot distinguish colors very well today. As we pass through that dark evolutionary tunnel, we lost many of the cone cells in our eyes responsible for color vision, and instead developed rod cells, which are far more sensitive to light. When the dinosaurs vanished, mammals stepped back into daylight. But some of them had grown so fond of the advantages darkness offered that they chose not to return. If you're going to hunt in the dark, the first rule is simple: capture every photon. This is where evolution's engineering comes into play. The retinas of nocturnal predators are fundamentally different from those of daytime animals. Their eyes contain much higher concentrations of light-sensitive pigments called rhodopsin. This pigment is so sensitive that the impact of a single photon can trigger a neural impulse. But nature didn't stop there. Many nocturnal hunters were gifted the famous tapetum lucidum, the layer you may recognize from your cat's glowing eyes. This is a biological mirror located just behind the retina. Light enters the eye, passes through the retina, strikes this mirror, and is reflected back through the retina a second time. In other words, the brain gets two chances to process the same image. The result? Where we see pitch-black darkness, they see with the clarity of a commando wearing night vision goggles. But what if there's no light at all? In the depths of caves, even a tapetum lucidum is useless. That's where active sensory systems take over. Bats don't see the darkness. They paint it by shouting. Bats emit sounds at frequencies far higher than the human ear can detect ultrasonic calls. These sound waves strike something as small as a mosquito, drifting through the air and bounce back. The bat's brain calculates the time it takes for the sound to travel out and return, taking the Doppler effect into account. Within milliseconds, it decodes the prey's speed, direction, and even the frequency of its wing beats. But wait, the story doesn't end there. The prey didn't stay defenseless. Some species, like the tiger moth, evolved ears capable of detecting bat sonar. And some go even further, emitting their own ultrasonic jamming signals to confuse the bat and disrupt its targeting system. This is one of the most advanced examples of electronic warfare simulation in nature. No eyes, ears pushed to their limits. What else is left? Heat. Some vipers, such as rattlesnakes, possess specialized pits between their eyes and nostrils, known as pit organs. These structures are nature's thermal cameras. The TRPA1 receptors inside them are so sensitive that they can detect temperature differences as small as 0.003 degrees Celsius. In total darkness, a mouse's body heat is like a bright light bulb switched on in a dark room for the snake. The prey thinks it's hidden, but its own body heat is quietly signaling the snake's brain, "I'm right here." Evolving to hunt in the dark is not just a lifestyle choice, it's an art of energy management. Large eyes, ultra-sensitive ears, and expanded brain regions all demand enormous energy, but the reward is worth it: less competition and more prey. So the next time you're lying in bed at night and hear a strange sound outside, don't be afraid. That's just the sound of evolution's flawless engineering, perfected over millions of years. When the lights go out, the real show begins. Thanks for watching.